we are coming back to confidence intervals. Where did I lose my pen this time? There it is. All right, ready? Guys. All right, so we have three major conditions that need to happen anytime we run a confidence interval for a proportion. The first one is it has to be random. All right, your second one is the 10% rule, and that is that the sample is less than 10% of the population. I guess we could do less than or equal to, but typically we want to keep it less than. Because if you're going to do anything more than that, yes, same rules. All right, last one is that rule of thumb 2 that we had talked about. That's your large counts. And that is NP is greater than or equal to 10, and N times 1 minus P has to be greater than or equal to 10. All right, now, it also asks, what do we do if the conditions are violated? All right, you can stop. Like, that is legit. If you can prove that one of these are severely violated, you can be like, yep, we're done, not doing it. However, you can still proceed with caution. And you do need to show that you have run these 3 checks every time you run a confidence interval. Okay, so literally every time we do it, I would be like, random, check. 10%, less than 10% of the population, check. Check those 2, put check, check. We can move on. All right, so what's the difference between the standard deviation of a statistic and the standard error of a statistic? So, standard deviation of a statistic is going to be the typical distance from the parameter. Standard error of a statistic is when the standard deviation is estimated. From the data. You guys might also want your blue sheets today, because I'm going to show you like a Z-star table, but I'm also going to teach you how to do it in the calculator too, but it does help on some of the questions. All right, formula for standard error. Standard error for p hat, this is on your blue sheet, is p hat times 1 minus p hat over n. And then because this is from when I've taught it previously, I literally have a kid who drew a Christmas Santa hat on top of the P. It's red and green and everything. All right, critical values. So the critical value is how many standard errors we need to extend write it, and I'm going to give you my email. Desired confidence to get. I don't know why it looks like an S. It's just sometimes if I don't pick it up enough, it kind of freaks out. So the critical value is literally a table value that we have to pull when we do these formulas. Okay? What it does is it helps us get to the desired confidence level that we want. So confidence level, this is going to be like your 90%, your 95. So 90%, 95. Those come with specific critical values. So they literally just become a number that you plug in to the formula and you move on from it. All right? So find the critical value for a 96% confidence interval for a proportion. So you got your blue sheets. All right? You guys got your blue sheets? You're going to want your blue sheets. We need to look at, I think so. Nope, those are T. We're looking at Z.
Oh, is that the middle bar?
You're right. Yeah. So, I'm pretty sure we need, is it that T table or is it this one? I don't think it's a T. I'm pretty sure it's this one. I'm pretty sure it's table C. All right, because you'll see the confidence level on it. Sometimes I put them in order. More B. C. Degrees of freedom, that's going to be like sample size. Okay? Freedom, yes. So, for this problem, we're just trying to find the critical value for a 96% confidence interval. Okay? Now, do I have a sample size? No. So, if there is no sample size, we end up using the Z star value. All right? Yeah. We end up using a lot of it in the calculator. Yes, 2.054 because I have a 96%, so it's 2.054. Literally, that's all we're doing, is we are using that table to find that T star value. Okay, so to do that, you're going to go 96 and then Z star down at the bottom. Okay? Like,
what is the number that we got? Oh, it's the critical value.
It's just a critical value.
Okay.
It's literally, you know, like how we look at gravity is 9.81. Gravity on the moon's different. Gravity on the moon, gravity on Earth. They're just different values based off of different sample sizes and different confidence levels. We're going to get to that. So for the most part, yes. All right. So what is the formula for a one sample Z interval? All right. So this looks really horrifically complicated, and I'm going to write it out, but it's on your blue sheet. All right. It's one sample, meaning you're just comparing one thing. All right. So it's P hat plus or minus Z star, which is the critical value, times your standard error. Well, I'm also going to show you guys how to do it in the calculator. All right, so this Z star, this is your critical value. Yes, for proportion. No, it's just like, it's just Z star. Hang on. Where's the Stu? It is the critical value. I am Z star. I was trying to see if it was on here. No, apparently not. We'll find it eventually. All right, but let me get the calculator up and running. It is on your formula sheet, but we don't use it a ton. I'm going to show you guys how to use it on the formula from the formula sheet, but I'm also going to show you guys how to do it in the calculator. All right, flip it to page, because now we're actually going to do a whole problem with it. Yeah, I bought it myself. $100. Depending on what calculator you bought, like yours might have actually come with it. No, you probably still have it. Sometimes you can contact Texas Instruments and be like, hey, I saw that there was this software. I have this calculator from when I got it in 8th grade. Can I install the software? Sometimes they'll be like, yeah, because you own the calculator. Why not? All right, so now we're going to get into actually doing all of this here in a minute. So we got calculators. All right, because you're going to want calculators. You're also going to want that table C, just kind of available. All right, table C. So students in AP Stats were told to estimate the proportion of pennies in circulation that are more than 10 years old. Okay, so I want to figure out the percentage of pennies that are more than 10 years old. All right, to do this, they collected a random sample of pennies. That's important. And overall, they found that 57 out of the 102 pennies were more than 10 years old. So the first part is just identifying the population and the parameter of interest. So what would be the population for this? That's the population? All pennies. All pennies ever made?
More than 10 years old.
How about all pennies currently in circulation? Right? That's my population. That's all of it. Now, the parameter that I'm looking for, I was going to say it's literally right above it. Freudian slip. Parameter. I was like, no, we had to figure out pennies. Yes, this one is percentage of pennies greater than 10 years old. No, I want to find more than 10 years in one day. I don't care. All right. Now, here's the thing. With pennies, you don't necessarily know, because if you look at a coin, it just tells you the year it was minted. You don't know when it was, so we just always assume if it's in that year. I don't know when it was happening. All right, so part B says check the 3 conditions. So what were our 3 checks again? Okay, so random. Yes, they explicitly said it. We are good. All right, second check is, do I think that 102 pennies are less than 10% of all the pennies? Yes. That is way less than 10%. All right? Yes. Yes. That's where they all show up. It's like socks. All right. Now, our last check is going to be n times p, and then n times 1 minus p, and I got to check those. Now, did you notice that they did not actually give you a percentage on this? All right. So, they gave you 57 out of 102. All right. So, I've got 57 over 102. That's my p hat. And then I got to multiply it by my sample size. Nope, wrong way. Is that greater than or equal to 10? Yeah, because the 102s will cancel, and 57 is definitely greater than that. And then I've got 102 times 1 minus 57 out of 102. It's possible, yes. At that point, I always just put like a big circle or something and just said proceed with caution, because most of the time, I mean, it's math class, they're going to force you to keep going through it, right? You just want to mark proceed with caution, but if it was the real world and you were actually doing a scientific study, you would stop, because things could go wrong and you could get bad data from it. We dropped a penny. More likely than not, if it's on a test, I'm going to make sure all of these pass. All right. So for this next part, we need to find a 99% confidence interval. Okay? So if we're doing this from the formula, remember our formula is over here at the bottom. It's p hat, all right, plus z star. So what was p hat again? Yeah. So 57 out of 102, plus and minus, all right. We have a z star value, or, yeah, we should have a z star value. All right, and then it's p hat, so 57 out of 102 times 1 minus 57 out of 2, because that was my sample size. Seem ridiculous? Yeah. We can definitely do this in the calculator, though. Oh, you're talking about the critical values? Like, why does it jump? So what happens is, this entire piece right here is your margin of error. Okay? So I have to add my margin of error to get my upper level. I have to subtract it to get my lower level. Well, if I'm upping my confidence, I'm narrowing that focus. Yes? Yes. All right. They told us they wanted a 99% confidence level. They tell us that. All right, so calculator time. Yeah, we're actually going to do it, but we're not going to do it this way because that's kind of icky. It's not that bad, but it could be better. All right, so I don't believe it's under here. Nope. Stat tests. All right, so we are under tests. All right. I'm going to write it down too. Because my instructions are from when I had the Inspires, and I was like, oh, it's menu 665. Like, this is still on C. So, it is stat tests. Yeah, should be 7. Oh, no, I'm sorry. A. 1 prof z interval. 1 proportion z interval. Yeah. Or scroll down. Sometimes you can scroll up too and it's faster. All right, so once you click that, it'll ask you, all right, how many times did it happen? 57. What was my sample size? What is my confidence level? Oh, over 1 more. 99. Very good. So, we're okay. I was like, I have to figure out what they're writing in. X is how many times did it happen? So 57 pennies is the X. So if I write it in, X equals 57, N equals 102. Confidence level, that's that 99. All right, now, when you're looking at this, they give you the p hat value, which is 57 divided by 102, but we knew that. Here's your confidence interval up at the top. So it's the 0.43, so 43%. So if I'm going to write my little confidence level, hang on, I got to scroll a little bit. We go purple. So it goes from 0.43219 to 0.68546. All right. So we are. Yep, because that's what we're doing on the next two. All right. So, have I run my confidence level? All right. Now I got to interpret it. All right. So, the interpreting is the whole sentence format from yesterday. Remember? Yes, we are. Yup. We're gonna the plus or minus. All right. How did the hang on, we're almost done. How did the interpretation go? Good. I put it in percents just because yeah. Percents we're angry. No. Children, stop with the angst. We're gonna be fine. We're almost done. So I don't care if you switch it from decimal to percentage. In my head, it makes more sense saying that somewhere between 43.2% and 68.6%, focus, 68.6%, like somewhere in there that contains my true proportion of pennies that are in circulation that are over 10 years old. All right, now, is it plausible that more than 60% of pennies in circulation are more than 10 years old? Yes or no? Why, yes. Exactly. That's all I need. No. That's it? Oh.